All right, so in this video, I'm hoping to give you an idea for the difference between a combination and a permutation. It's a little backwards because in our day-to-day life, like if I give you, 4, 8, 7, and I ask you about the number of combinations, that's usually the language that we would write. But that's not really accurate here. There's actually a different type of definition that we need to give the word combination. At least that's what's given to it in all the math books, right? So what we're going to do here is I've got 6 letters. And what I want to do is from those 6 letters, we're going to choose, let's just start by choosing 2 of them. And I'll actually list these out, because we can do 6, choose 2 relatively easy. All right. So if I do AB, that's 1. That's one way to choose 2 from those 6. Or AC, or AD, AE, or AF. All right. If I wanted to, I could do BC. I could do BD. I could do BE. I can actually list these out. It won't take me all day long. I could do CD, CE, CF, and I could do, D, all right? I could do DE and DF, and then the last one I could do is EF. So this is all the possible pairings for these 6 letters, all right? Now, I know I didn't mention it, but in these pairings, I didn't care about the order. So AB was the same as BA, all right? I wasn't taking that into consideration at all. It's like I'm taking these 2 kids on a trip or something like that, all right? Or I'm giving these 2 kids one job to do. Now, a different question would be, how many ways can I choose these 6 from the 2, choose two items from the 6 where the order matters. So that might be like you've got 6 options, but you're choosing 2 of them to do 2 specific jobs, all right? Or maybe one of these is getting a first place trophy and the other is getting a second place. In that case, AB would be different than BA, all right? And this is going to be the difference between these 2 words. For a permutation, right? For a permutation, the order does matter. All right. So I'm gonna actually just gonna call this ordered, and a combination would be non-ordered. All right. We don't care about the actual order that they come in. We just care, what's in the group. All right. So let me erase these here. All right, so we were able to list those out. Oh, I didn't even count them. I should have counted them. Anyway, this time, instead of choosing 2, we're going to choose 3 of them, but I'm not going to list them out. I'm going to use our multiplication rule from last time, or our counting principle, and we're going to do the permutation one first. It turns out the one where it's ordered is actually a little bit easier to deal with. So if I was thinking of ABC, all right, that would be different than ACB. That would be different than BCA. That'd be different than BAC, or different than CBA, and that would be different than CAB. Now, for these 3 letters, all right, A, B, and C, that's actually all the ways that I can mix and match them, all right? But this is all the different permutations for those 3 letters, all right? But I want them all. Like, I want to be able to choose, instead of just ABC, I want to be able to do ABD, ABE, ABF, BCD, BEF, all of them. I want all the possible permutations. We actually did something like this last time, all right? It's kind of like you have 6, what could we call this? You've got maybe 6 candidates for a job, and you have to fill 3 positions. All right. So for that first position, you actually have 6 possibilities to choose from. All right. And in that second position, you have 5 possibilities. And in that third position, you have 4 possibilities. You filled all 3 jobs now, right? So whatever this multiplies out to looks like 120. That would be all the permutations of choosing 3 objects from a group of 6. Now, I didn't have to list them out, thankfully. Woo. The combination one, though, let's just take this ABC. See, for a combination, the order doesn't matter. So if I have ABC, that means I also have BCA and BAC. This would be kind of like, all right, I've got 6 candidates, but I just want to fill 3 jobs. I don't care who goes where, and I'm just a bad manager, and I just want to fill the positions. All right. So if I have 3 chosen candidates, this is good enough for me. But this doesn't tell me how many possible combinations there are. So I could have ABC, but I also could have ABD. I could have AEF. There's a lot of different ones. So the way that I like to think of this is for every 6 of these, like these 6 right here, or I should actually say this one right here, actually covers all 6 of those, right? And if I had another one, let's say I had ABF, right? I know that this ABF would cover 6 more permutations over here on the left. So this ABF would cover AFB, BAF, FAB, all. There's going to be 6. There's going to be 6 permutations. All right. There's going to be 6 permutations of ABF over here on the left side. And this one combination is going to cover all 6 of those. So if I know that there are 120 specific orderings, total specific orderings, and I want to know how many combinations there are, well, since each one of these is covering 6 of these on the left, I can just divide that out. So if I do 120 divided by 6, that's going to give me 20. There are only 20 combinations for choosing 3 objects from 6 objects. All right. Now, the notation wise, it gets a little weird. Let's look at something similar here. Let's go with, actually, let me pause. All right, so got another one here real quick. So let's say that you were, I don't know, at a movie festival, and there's 8 movies showing, and you're trying to choose which of the 4 movies you want to watch. All right. Now, first off, you have to ask yourself the question, does the order here matter? And it might matter to you. Probably, as long as you choose your 4 favorite movies, I think you're going to be okay. So if the order doesn't matter to you, then, all you're really caring about is a combination. So we're going to work up the number of combinations. All right. But at the same time, let's say the order in which you watch the movies, I don't know why it would. All right, but we're also going to figure out the number of permutations in choosing 4 objects from 8 objects, or watching 4 movies from 8 movies. All right, so I guess like watching Jaws and Zootopia, then watching Die Hard, then watching Broken Arrow. Those would all be, that would be different than watching those 4 movies in a different order. All right. So let's work on the permutations part first. All right. So you've got, we're wanting to find all possible ways that you can watch, in different orders, 4 movies from the 8. So we're going to set up our little multiplication rule. For the first choice, you have to choose one of those 8 movies to watch first. So that's going to be 8. Then you have to choose, from the remaining movies, a second movie to watch. So for your second choice, you have 7 options. For your third choice, you have 6 options. And then for your fourth choice, you have 5 options. All right, so if I multiply these all together, let me see what I get here. Let's see here. 8 times 7 times 6 times 5. So there's 1,680 options. All right, that's all the possible permutations. But if you're just considering the combinations, it's going to be a smaller number here. For instance, let's look at that. So what was that? I said Jaws. I said Broken Arrow, Die Hard, and Zootopia. So if you were looking at permutations, JBDZ would be different than JDBZ, all right, or ZBDJ, all right. And since you have 4 objects here, you're gonna have a lot of ways that you can rearrange those 4 objects. And in general, all right, you want to ask yourself, how many ways can you arrange those 4 objects? Well, we had a word for that before. All right, this is where the factorial comes in handy. So since you have 4 objects and you're rearranging those 4 objects, right, there's going to be 4 factorial ways of doing that. 4 factorial was 4 times 3 times 2 times 1. So that's going to come out to ... There's going to be 24 permutations, 24 possible ways that you could watch those 4 movies. All right. But see, all 24 of these would be covered up here by just that one combination. Okay. So this one combination will cover all 24 of those. But in total, I know that there are 1,680. There's going to be 1,600 different possibilities of movies to watch as far as the order goes. But if you want to know how many just regular old combinations there would be, I'm going to take this 1,680 and divide it by my 4 factorial. I'm going to divide that by my 24. And that's going to give me the number of combinations. So that divided by 24, that gives me 70, only 70 combinations. So if you don't care about the order in which you watch these movies, if there's 8 movies to choose from and you're only watching 4, there's only going to be 70 possible combinations.